This is lesson 11.6, area of parallelograms, triangles, and trapezoids. The base of a parallelogram is any side of a parallelogram. The height is the length of an altitude or a line segment perpendicular to the base with endpoints on the base and the side opposite the base. Okay, so the base can be any side of the parallelogram, but then the height is the line that goes directly from the base to the side opposite the base, and it's perpendicular, which means, remember, that it makes a right angle. Okay, so the formula for the area of a parallelogram, the formula is just base times height. And to make that a little easier to see why that makes sense, and also to see what the base and the height are in a parallelogram, let's take a look at this. Okay, so you can see we have a parallelogram. Here's the altitude, or the height. And then we can take that piece of the parallelogram and slide it over, and that makes a rectangle. And again, you can see the base and the height. And those two triangles are the same. So that shows you why this formula makes sense, because I could take, just like this dotted line is drawn right here, I could take this little triangle here and slide it over to here, and it would complete this whole rectangle. So it's really like length times width for a rectangle, except the part of the rectangle's on the other side. It's a parallelogram. So base times height. So for our examples, we want to find the area of each parallelogram. So for the first one, since it's a parallelogram, we want to use the formula A equals BH. And the base is the only side that we actually have a measurement of, is this one. So this is the base. And that means that this one that makes a right angle with the base, this length must be the height. So the area is the base, which is 32, times the height, which is 14. And if we multiply 32 times 14, we get an area of 448 square centimeters. Let's do the same thing for B. So again, we have the formula A equals BH. And here, again, the only side that we actually know the length of is 7.5. So this has to be the base. And then that would make this length the height, because it goes from this base to the side opposite the base, and it makes a right angle. Even if it's not drawn inside the parallelogram, it can be drawn outside, it's still the height. So we'll replace the B with 7.5, and we'll replace the H with 10.2, and we'll multiply 7.5 times 10.2, get an area of 76.5, and this one will be square feet. Okay, so there's two try-it-yourself problems at the bottom of this page. Go ahead and pause the video and work through those two problems. Press play when you're ready to check your answer. For the first one, we should get an area of 72 square yards. And for the second one, we should get an area of 32 square meters. Okay. On the next page, we see two more shapes, a triangle and a trapezoid. And we have, again, the area formulas for each one. And again, we'll look at just an example of an animation that shows why those formulas make sense. So let's first look at the triangle. So we start with the triangle. And then we make a copy of this triangle just to help with the illustration. So these two are the exact same size, they have the exact same area. And then when we rotate the one and slide it together, Notice here we have a parallelogram that has the same base and the same height as the original one. So 2 times the area of the triangle would equal the area of the parallelogram, which is base times height. Well, since we only want one triangle, we just take half of that. Okay, so that tells us that this formula makes sense. Area for a triangle is 1/2 base times height. Now for a trapezoid, this one is a little more tricky. So it's very similar to what we did with the triangle, though. So again, we make a second copy of the trapezoid, and then we slide them together. Now here, we end up with another parallelogram, but the length of the base is actually the base 1 plus base 2, because these two had different lengths. So we get base 1 plus base 2 times the height. And then again, because it's 2 trapezoids to get that, we cut it out in half to get the area of just one trapezoid. Okay, so that is where that formula comes from. So sometimes you'll see this formula written with A and B, where A is one base and B is the other. Or you can also see it written as 1/2 H times base 1 plus base 2. So, and I think more often than not we see it written with this and not with A plus B. So just be aware though that those are what letters or anything that we use to represent something doesn't change what it is. It just changes how we're actually showing it. So it's still the same formula, it's just a different selection of letters. Okay, so for the next example, we want to find the area of the triangle. And we know that the formula for the area of a triangle is A equals 1/2 BH. So let's start with our formula. A equals 1/2 BH. Well, for a triangle, just like with a parallelogram, the base has to be one of the sides. So here, the only side I know a measurement of is the 16 yards, so this has to be the base. And then from there, the height should be perpendicular to the base. So here's where I see the right angle. The height goes straight up from that, so that's 11.7. That's the height. And now let's substitute those numbers in. 1/2 B, which is 16, times H, which is 11.7. And we'll go ahead and multiply those. Remember, if you want to multiply those in a calculator, you can just put in 1/2 as 0.5. Makes that a little easier. And we should end up with 93.6 square yards. Okay, for number 3, find the area of the trapezoid. So we're going to want to write down our trapezoid formula to begin with. A equals 1/2 H times B1 plus B2. And then we want to make sure we label everything. The bases need to be the 2 sides that are parallel. Remember, a trapezoid has exactly 1 pair of parallel sides. It doesn't matter which one's B1 and which one's B2. So these are our 2 parallel sides. So let's say this one is B1 and this one is B2. The height is always the vertical distance, or if the trapezoid is turned a different angle, just the perpendicular distance from one base to the other. So you're looking for that right angle marking again, just like the height of a triangle or a parallelogram. So you see that right angle, this is the height. So we have H, we have B1, we have B2. These numbers are actually not useful for this problem. So let's go ahead and substitute the numbers in that we have. 1/2 H, which is 17. B1 is 7. B2 is 26. And be very careful if you're going to do this on your calculator. You cannot type in 1/2 times 17 times 7 plus 26. You either need to do this portion of it first, or you need to make sure you have parentheses around this. Otherwise, the calculator will multiply these 3 things together and then add 26. And you can see from the parentheses here that that's not the way that should be changed. So if you put that into the calculator correctly, you should come up with an area of 280 0.5 millimeters squared. Okay. There's two try it yourself problems right below these, so pause the video, work through those two. When you're ready to check your answers, press play. Alright, this first one has an area of 22 square meters, and the second one has an area of 33 square kilometers. Okay, let's move on to section 11.7 and look at different shapes. And look at circles and circumference. A circle is the set of all points in a plane that are the same distance from a given point in the plane. And that given point is the center of the circle. So you see a circle here, and here's the center. The distance from the center to any point on the circle is the radius. So here's the center, here's a line drawn from the center to a point on the circle. This is a radius. I could also draw a radius going down this direction, or out this way, or over here. It doesn't matter. Any segment that goes from the center of the circle to an outside edge has the same length, and that is the radius. The distance across the circle through the center is the diameter. So that's this full length through the center. The circumference of a circle is the distance around the circle. So it's like perimeter, but for a circle. And the formula for those, there's two formulas we can use depending on whether we have the length of the diameter or the length of the radius. But for the diameter, it's just c equals pi times d. But if we have radius, it's c equals 2 pi times r. So we just want to make sure we're using the correct formula for what information we're given. So for the first example, it says to find the circumference of the circle, round to the nearest tenth. And I see here that we have the radius, since it just goes from the center to the outside. So I don't want this first formula, I actually want the second one, c equals 2 pi r. And this is the only measurement in the circle. This says the radius. So I know I can substitute that in place of r in the formula. So c equals 2 pi times 4. Okay. Now, surely you've heard in previous math classes that pi is approximately 3.14. Well, we're at the point where we're using some pretty high-tech calculators, and that calculator actually has a button on it that you can use for pi. That is the button that we will need to use when we do these calculations, because 3.14 is only approximate. And truthfully, the number your calculator has is also approximate, but it's much, much, much more precise than 3.14. So, make sure you are using that button. If you're having trouble locating it, it is the same button that you use for exponents. It's right below the clear button. And it's probably, you have to hit the second button before you hit that exponent button to get the pi symbol. You should be able to find that. Look kind of closely at your calculator. You should be able to find the pi symbol if you didn't already know where it was. So if we type this in, 2 pi times 4, it should give a circumference rounded to the nearest tenth of 25.18. Okay. For the try-it-yourself problem, you're going to do something similar. Make sure you notice whether you have the radius or the diameter and use the correct formula accordingly. And also make sure that you're using the pi button on your calculator and not just 3.14. So go ahead and work through that problem. When you're ready to check your answer, press play to continue the video. And here we should get a circumference of approximately 28.3 kilometers. And really, I should have used these squiggly lines for this one too, since we rounded this off. See, it's approximately 25.1, not exactly. Okay, let's continue. You can also use the circumference of a circle to find the diameter or the radius. So this is basically like working backwards. but we'll still use the same formula, we'll just solve it a little differently. So example 2 says, Arlene works at a retirement home that has a circular community garden with a circumference of 30 meters. And we see that in this picture. Here's the circle, the circumference all the way around is 30 meters. She would like to use some edging to divide the garden down the center. What length of edging does she need? So she wants to put a divider made out of edging straight through the center of the circle. So we are looking for the diameter. Well, we have the circumference, we're looking for the diameter. The formula we want is the one that relates circumference and diameter. C equals pi d. And now we'll just replace the numbers we have. So if we have the circumference is 30, we'll replace C with 30. And we don't know d, so we'll just leave that as d. Okay, now just like any other equation at this point, I want to solve for d, and right now d is being multiplied by pi. So if I want to get rid of this pi, I would have to divide. So pi's will cancel. Pi divided by pi is just 1, so we're left with just d. And then let's go ahead and divide 30 divided by pi. Don't forget to use the pi button on your calculator. Don't use 3.14. And it should come out to approximately 9.5. So what length of edging does she need? She needs about 9.5 meters. Okay. For the last try it yourself problem, you're going to do something similar. So pause the video, work through that problem. When you're ready to check your answer, press pause. Okay, for this one, how tall is Jenna's dad? You should have gotten about 6.5 feet tall.